Welcome you all to the class. Here, today we are going to discuss about Chap 1, real numbers. Okay, you all are familiar with real numbers. In class 9, you have already discussed about the different types of real numbers. Okay, so let's quickly have a list what you learned in your previous classes. Okay, so when we went like in starting from our basic of class 5, you learned the natural numbers. Okay, so you learned in natural numbers like starting with 1, 2, 3, 4 onwards, and we call them as counting numbers. Okay, then we extended our group and we included zero in it. So you gave the name of a group as a whole numbers. So whole numbers are nothing but zero along with natural numbers 1, 2, 3, 4 onwards, isn't it? And then further extending the group. See, these groups or these numbers are nothing but the set of the numbers, numericals, all the object, and how we call it as a set. It's a group of object feeling certain conditions, the similar conditions. So here the natural numbers is a group of natural numbers, that is these are counting numbers. जब उसमें zero add किया, we got a new group that is group of whole numbers. Similarly, when we extended here with the negative numbers, okay, we call them as integers. Integers are nothing but, you can say, the negative numbers that is opposite of natural numbers. So, which we write it as minus 2, minus 2, minus 3, 0 means along with the whole numbers, opposite of naturals are also considered. So 1, 2, 3 numbers. Or you can say these are the positive ones, 0 and the negative integers. So I can generalize like integers are nothing but the group of numbers having natural numbers, 0 and negative of natural numbers. That is opposite of natural numbers, right? Then we extended that what about the numbers which are not part of this. So example is 2 by 3, okay, or minus 2 by 3, or 5 by 7, or 19 upon 11. Such kind of numbers, if you are familiar with this field, when I use a positive, you learn them as a fraction, means a part of something, a part of a whole. Okay, so you took them as fractions, but when we group them under this, they did not follow any of the category here. So what we say, we describe rationals here as any numbers is of the form P by Q, where P and Q are integers. And what is the condition for Q? Q should not be equal to 0. I hope it's clear to you. That it is of the form P by Q. So any number which you could write as P by Q using any of the integers, if you write them as P by Q form, then you get a rational number, but what should be the condition? The q cannot be 0. That is, the denominator cannot be 0 here. Okay, that is the condition. So which we gave you as rational numbers. So when I was talking about fractions, yes, you can say these fractions are nothing but positive rational numbers. So like rational numbers, when you have, you will get positive, 0 and negative. Now, the general confusion is like, is 0 a rational number? So yes, 0 could be a rational number because you can write 0 as 0.5 or 0.100. So you can express 0 as P by Q form. So yes, it is a rational number. After that, in your class 9, you dealt with some numbers which are different from rationals. So that means there were some numbers when you learned, especially the square root by division method. Okay, you learned that there are some numbers, okay, which cannot be expressed as P by Q form. So we call them as irrational numbers. So irrational numbers, you have many definitions for irrational, like more concepts. So not in P by Q form, we call them as irrational numbers. Or if you take the whole system as a decimal system, then we define irrational as non-repeating and non-terminating. So that means those decimals which are not repeating and not terminating, neither of repeating nor of terminating. Such decimals are called as irrational numbers. And finally, the real is the whole of it. That is, here what was the biggest? Now you know that natural is a part of rational, whole numbers is a part of rational, Integer, yes. So rational was the group which included all these. So here the rational and this was different. So rational and irrational together. Okay, rationals and irrational together form the group of real numbers. Okay, so this is what you learned in your lower classes. Okay, about the real numbers. Now, apart from real numbers, again we are going back to simple the positive integer part, and we learned the new thing about it. Though I say it's a new concept, but yes, you have already done this in your lower classes. We are just applying it in a different way here. Okay, so what does it say? So try to pay attention. What does it say here? That when you divide, you're familiar with arithmetic, you are already learned the concept of division. ठीक है? तो डिवीजन में आपने क्या सीखा था एकदम छोटी क्लास में जाए तो what did you learn? That suppose I divide 25 with 3, okay, and if you write 3 8s are 24, okay, and this is the one, the division ends here, isn't it? So you're familiar with this concept. And how did you learn this in class 5 and roses? So you learned the concept that is 25 would be written as divisor into division plus quotient. I mean, dividend is equal to divisor into quotient plus remainder. You learned this concept. Okay, so this is what we generalize here in form of Euclid's division lemma. Okay, what does Euclid division lemma says that okay, what does it say that if I say this is the dividend and if I say this is the divisor, okay, there are two positive numbers, say A and B are positive numbers and such that A is greater than B. If I take it, then it always the return is A is equal to BQ plus R. Okay, and what do you know about A is equal to BQ plus R here? That you can write down this as okay, BQ plus R, and here there is some condition for this. Now look at this again. If I take some other example, say 2 divided by 27, then 2 ones are 2, 3s are 1. Okay, so again I can write this 27 as 2 into 13 plus 1. So that means any positive integers can be returned as something like this. So that means A is equal to BQ plus R. Now what is this Euclid division lemma? When I generalize it, it is if A and B are any two positive integers and A is greater than B, and A is bigger than B, then we can divide and definitely there will be two integers Q and R. Okay, we will make use of two positive integers Q and R, and with the help we can write this as A is equal to BQ plus R. Okay, because Q is nothing but the quotient and R is nothing but the remainder. And what is the condition for R? Like you go on doing the division. I did here in one step, I ended, then I ended after two steps. Till what? Till I get remainder lesser than the divisor, isn't it? Yes, that is the condition for R. So that is the Euclid division lemma. So generally that comes as a statement. There will be many more application for this. That what is Euclid division lemma, and to utilize that like finding HCF of number. So how the question comes on the board? What is Euclid's division lemma? The statement. Then what is the condition for the remainder using Euclid's division lemma? And application of Euclid's division lemma. So in other ways, you get these questions. Okay, so I hope this is clear to you. So what does Euclid's division lemma? That if A and B are any positive integers such that A is greater than B, then what is this? Can you see this reverse A kind of symbol? It's a symbol. The meaning of it means it depicts there exist Q and R such that A is equal to BQ plus R. And what is the condition for it? 0 less than or equal to R. That is whenever you divide any number, okay, by a given number, what do you get? Either you get remainder 0. So like for example, if I divide by 2, I'll take a smaller example. Either I get 1 or I get remainder 0. So only two cases whenever you divide any number by 2. Either the remainder is 0 or the remainder is 1. Similarly, when you divide it by 3, so either the remainder is 0 or 1 or 2, like that. Okay, so I hope it is clear that So in this way, if I generalize it, what do I get? So here, remainder will be, it can be any, but it always lives there, your divisor. Okay. And now, what's the use of this theorem basically? So it is used to find out the HCF of number. Now here in your textbook, you will find that there is one more word using Euclid's division algorithm. Now what is algorithm mean? Okay, so here this is lemma. Lemma is like, you get some proof or statement which is true. Then we call it as a lemma. And using the lemma, that using the statement, if we have something to prove stepwise, we go as an algorithm. Okay, so this lemma, we use it to find out HCF. Okay, now this concept of HCM and LCM, we have done it in the lower classes. Okay, so we utilize that to find out HCF by Euclid's division lemma, and we are using Euclid's division lemma, but we are following certain steps. So we may call that sometimes it is written as Euclid division algorithm also. So how it has to be done? Say for example, we are taking it as a 25 and 80. Okay, so you have learned either the factorization method that you write this way 5 into 5, and 80 could be written as say 2 into 2 into 2 into 2 into 5. Okay, and then you go for common factor and you write HCF as 8. HCF is 5. Okay, or the other way is you learn division method in your class, lower classes, that is your class 5. If I follow that, you use this. You remember, out of these two numbers, you write bigger number here. Okay, it is called continuous division method. Okay, so you divide it here, say 25, 3s are 75. So 5 is left. Again, this remainder will act as a divisor, and the divisor becomes the division. I hope I'm clear. जो भी आपको remainder मिला, okay, that will act as a divisor. और जो पहले वाले step का आपका जो divisor था, वो यहाँ division बन जाएगा. So when we divide the division, and we will continue this. यहाँ पे ये दो step में end हो रहा है. It might happen that it go on extending for 4 to 5 to 6 steps. You continue this till you get 0. Okay, and once you get the 0, your divisor is your HCF. So that is HCF is 5 here. अब इसको लिखना कैसे? Okay, we are not following this method here. Then it is 80. How did you write this? Just now we got dividend is equal to divisor into quotient plus remainder. That is A is equal to BQ plus R. So 80 is nothing but 25 into 3 plus 5. Okay, and then second step of division. So 25 is written as 5 into 5 plus 0. And this was our divisor. So we get HCF plus 5. So this is the way that using the Euclid division lemma, that is, these steps are important here. Children, see, this is the work part, working column part, it comes under working column part. So you do this, unless you write that, you don't get full marks in your exam. So these are the main steps that using the Euclid division lemma, you can find out the HCF of two numbers. Sometimes it may be like these are the also, it is like this type of method is also included in our class 10, but you have to look for the question. What does it ask you? If they are saying using Euclid division lemma find HCF, then you do not go with this method. Strictly you will adhere to this method. I hope I'm very clear with this.